In lesson 4, we're going to look at how to multiply and divide radical expressions. So one rule that we need to remember before we actually do this is that the square root of a times the square root of b is the same thing as the square root of a times b. So this rule is going to help us actually go through and multiply. So multiplying, you do not have to have the same thing underneath the radical like you do for adding and subtracting. So multiply, you're just going to multiply right across. So a times b will be under the same radical. Now, one thing to keep in mind though, when you're doing this, you need to make sure that you have the same type of root. So here I had a square root times a square root. So it was the square root of the entire thing. If it was a cube root and a cube root, it would work. But we wouldn't want to combine a cube root and a square root because those have different fractions as exponents. So it would be bases with different powers, so you wouldn't want to combine them. So if you look at this first example, we're going to go ahead and we're going to multiply our coefficients. So 3 times 2 gives me 6. And since I have a square root times a square root, I'm going to go ahead, I'm going to multiply the numbers underneath the square root. So 5 times 7 is going to give me 35. So then that's it. And if we could reduce it, we would. Otherwise, we'll just leave it as is. So multiply the coefficients, multiply the numbers under the radical. So then looking at this next example, now we're going to want to distribute this radical 3 since there's parentheses. So I'm going to keep the 2 out in front of that 2 radical 6. And now I'm going to combine 3 times 6, so I get square root of 18. Keep the minus, keep the 5 out in front. 3 times 12 gives me 36. And now we're going to look at simplifying. So I have a 2. This radical 18 will break down as 9 and 2. And then the square root of 36 is just 6. So this is then going to be times 6. Remember that this operation between the coefficients and the radicals is multiplying. So now I have 2 times 3, because that operation's multiplication, minus 30. And now I can combine these, so I have 6 radical 2 minus 30, and that's as far as I can simplify, because remember when you're adding or subtracting, you have to have like radicals or similar radicals in order to be able to combine those terms. So operations with radicals are much like operations with polynomials. When you multiply, you can combine anything. When you add or subtract, you have to have like terms. So here I'm going to multiply 2 radicals times 2 more radical terms. So I'm going to use the box method that we learned when we multiplied a binomial times a binomial. So I'm going to just kind of apply that here just as a way to help organize this. So radical 3 plus radical 5 on one side. Then I'm going to have 4 radical 3 minus radical 5 on the other. And then we're just going to go through and we're going to multiply every single piece. So 4 times radical 3 times radical 3 is ended up going to be the square root of 9. Then I'm going to have here 4 times the square root of 15. Up top here I'm going to have a negative 1 times the square root of 15. And then down below I'm going to have a negative square root of 25. Now you might be thinking in this box here and in this box down here, I could have just said 4 times 3, because when you multiply a square root with the same number by itself, it's going to cancel out the square root and you're actually going to take the square root. Same with this. This could have been just minus 5, because square root of 5 times square root of 5 is just going to be 5. But instead I have it in this step here. So what I'm going to do now is I'm going to rewrite this. So I have 4 times 3 when I take the square root of 9. My like terms are in the diagonal here. So I have plus 3 square root of 15 when I subtracted the 4 minus 1. And then here I'm going to have just minus 5. So now I'm going to combine these. So I have 12 plus 3 radical 15. If I could reduce that radical 15, I would, but I can't, so I'm just going to leave it. So now the only thing that I can combine are these numbers as my like terms. So I have 7 plus 3 radical 15. So let's do a couple more so you get used to the process. So here's another example. It's like a binomial term. You have two terms. So I'm going to use the box again. So I have square root of x plus 3 times the square root of x plus 3. Again, make sure that you don't think of this as being able to distribute that squared through to each piece, because here my operation is addition. So you actually have to make sure that you do square root of x plus 3 times the square root of x plus 3. It's not the same as just squaring each piece. It doesn't follow that exponent rule because it's an addition sign between the two terms. So here I have the square root of x squared when I multiply. Then I have 3 square root of x, 3 times the square root of x. I'm multiplying, I get plus 9. My like terms are here. So when I square root x squared, I'm going to have x plus 6 square root of x plus 9. Because I combined my like terms, 3 and 3 gives me 6, and square root of x, and then I just added on my 9. Here's another one. So same idea. So I have 3 square root of x minus 2 square root of y. Again, you have to make sure that you have it for both parts or both sides of your square. You're multiplying it twice. So I have 9 times the square root of x squared. So remember, I'm multiplying the coefficients. Again, multiply the coefficients. 3 times negative 2 gives me negative 6 square root of x times y. Down here, I'm going to have 3 times negative 2, so negative 6 times the square root of x times y. And then here, I'm going to have positive 4 times the square root of y squared. Again, my like terms are in the diagonal. Now notice that if I would have done the square root of y times x, and then up here, square root of x times y, it's the same thing, so you just have to recognize that. So just pay attention for that. So I have, combining like terms, 9 times x, because when you take the square root of x squared, it's just x. Combined your like terms in the middle, so we have minus 6 minus 6, so minus 12. Carry along the square root of xy, and then plus 4y. And then here, we're going to do the same exact thing. So we have square root x plus 2 minus 1, square root x plus 2 minus 1. So here, I'm going to have the square root of this entire thing, x plus 2 times x plus 2 squared. So you could, if you really wanted to, you can multiply x plus 2 times x plus 2, but you'd have to do your own your own rectangle just for that. I would leave it just like this, though. It's going to make it much easier because you're going to see that it's going to cancel itself out. Some of you might be able to just look at this and say if I'm multiplying a radical times a radical with the same thing underneath, this box here is really just going to be an x plus 2 because the square is going to cancel out with the square root. Then I go over here, I'm going to have a negative square root of x plus 2. Down here, negative square root of x plus 2. And then I'm going to have a plus 1 down here. So combine your like terms. I end up with an x plus 2 minus a 2 square root of x plus 2, because this is a coefficient of 1 and 1, so you get minus 2. Carry along that square root of x plus 2. And remember, this here came from the fact that when you square something in square root, they cancel each other out. And then I have the plus 1 at the end. So the only thing that I'm going to be able to combine here are my like terms of 1 and 2. So I'm going to have x minus 2 square root of x plus 2 plus 3. And that plus 3 you could have put in the front. It doesn't make a difference. Alright, let's look at a couple more. So here I have another example. So radical 6 plus radical 2, radical 6 minus radical 2. So here you're going to get the square root of 36 when you multiply. Here you're going to get the square root of 12. Over here when you multiply, you'll get the square root of 12. And then you'll have a minus square root of 4. So your like terms, so when I go to combine these, square root of 36 is 6. My like terms here end up canceling because you have a minus 12 and a plus 12. And then here you're going to be left with the square root of 4, subtracting off the square root of 4, which is 2. So we're left with just 4. So basically, if you compare this example to the other ones, this one is a lot less complicated because of the fact that I had a plus and a minus between the two terms that were the same. So these two radical expressions are called conjugate pairs because what happens is the radicals end up canceling, the middle terms end up canceling out, or the more complicated pieces always cancel out. So if you go back and look at these previous examples, the complicated pieces never canceled because I always had the same sign. I did a 2 plus, I multiplied by a plus and a plus. Here I had a minus and a minus, and then a minus and a minus. So the middle terms are always the complicated terms. They're always the part with the radical because those radicals didn't cancel. So when you have conjugate pairs, meaning you have opposite signs, those middle terms with the radicals are going to cancel. So these are called conjugate pairs. And these are actually going to be helpful for when we divide. So when you look at this next example, if you remember when we simplify radicals, we can't have radicals in the denominator. So if I want to get rid of both of these radicals, what you need to do is you need to multiply by its conjugate pair. Because if you look at example 7, see how when I multiplied two conjugate pairs, the radicals were completely gone. And I was left with the whole number. So that means whenever you have a radical expression in the denominator, you need to multiply by the conjugate pairs. So let's just write that down. Because the product of two conjugates is a rational number, meaning a whole number or a fraction, but basically not a radical, then we are going to multiply the numerator and denominator by its conjugate, by the denominator's conjugate. So what that means is I'm going to take this expression, so let me just rewrite it, and I'm going to multiply the top and the bottom by the conjugate. So the conjugate means switch the sign. So here it was minus, so that means I need to switch the sign to plus. So I'm going to multiply the top and the bottom by the conjugate. So up top, when you distribute, you're going to have 6 radical 5 plus 6 radical 3. And on the bottom, since we're multiplying by the conjugate, really what you just need to make sure you multiply is the first terms and the last terms. Because those middle terms, if you set up the box like we did in this example, the middle terms cancel. So essentially what I did in this example was multiply the 2 radical 6's and the 2 radical 2's. So since the middle terms cancel, we know that we have to be left with the square root of 5 times the square root of 5, which is going to be 5, minus, it'll always be minus, the square root of 3 times the square root of 3, which is 3. It'll always be minus because you're going to be multiplying a negative times a positive, which will always be a negative. So then up top, you're going to just keep what you have, 6 square root of 5 plus 6 square root of 3. Notice I didn't combine those because I had different radicals, so I can't combine those. And now when I look at this, I can reduce this because you end up with 6 radical 5 over 2 plus 6 radical 3 over 2. So since it's addition between the two terms, you have to make sure that you can rewrite this as each piece over the denominator. So now I can cancel those and I get 3. Here I can cancel and I get 3. So I have 3 radical 5 plus 3 radical 3. So let's look at one more example like this. So we're going to rationalize the denominator. So let me just rewrite it down here so I have space. So I have square root of 5 minus 2, square root of 5 plus 2. So again, we're going to rationalize, which means you need to multiply by the conjugate of the denominator. So look at the denominator, and it has a plus, so that means you need to multiply by a negative or a minus. So your conjugate is always of the denominator. So you're going to multiply the top and the bottom by square root of 5 minus 2. So in the denominator is going to be easy because since these are conjugates, we know that we're going to have just 5 minus 4. So I basically just multiplied radical 5 times radical 5 and then the last terms. 2 times negative 2, so I got minus 4. Up top, though, these are not conjugate pairs, so you might want to do a box off to the side to help visualize what's happening. Otherwise, what you can do is you can just think of multiplying radical 5 by each of these terms, and then multiplying minus 2 by each of these terms. So essentially you're foiling or you're distributing each of these. So here I'm going to have 5 if I go back over to the box. And I just multiply each of these pieces. Combine your like terms. So I have 5 minus 4 radical 5 plus 4. 5 plus 4 is 9. So 9 minus 4 radical 5. So I'm just going to put this back into my problem over here. So I have 9 minus 4 radical 5. And then we're just going to simplify this. So up top I'm going to stick with the 9 minus 4 radical 5. On the bottom I'm going to have 1, which really means I don't really need that 1, because if you divide anything by 1, it's just going to be whatever you started with. So you end up with 9 minus 4 square root of 5. And that's it.